All right, we're looking at homework number 10, solutions. I'm going to scroll through the answers quick. You can pause it as you need. Then I will explain them. Okay, so once you've checked it, you could scroll forward on the video and only watch the ones that you have questions about. Okay, I'm going to start and do them all. Here we go, in order. Number 1, since 4 is a perfect square, you can take the 4 and make it into 2 squared. But then, of course, that is to the 6th power. And 2 squared to the 6th power would be 2 to the 12th. Because when you have a power to a power, you multiply them. The 8 can be changed into 2 to the 3rd power because it's a perfect cube. Then, since the 8 was to the 5th power, this would be 2 to the 3rd to the 5th power. And you'd use the power to a power to make it 2 to the 15th. The 25 is a perfect square. It's equal to 5 squared. That would be to the 7th power because 25 was to the 7th power, and this is still 25 in here. That, of course, would be 5 to the 14th power when you use the power to a power rule. And last up, 9 is a perfect square. So 9 can be changed into 3 squared. That, of course, was to the 10th power, so it still is to the 10th power. And when you simplify that, you get 3 to the 20th. Number 5, 2/5 to the 12th power is already simplified. However, on the other one, you have 2/5 to the 5th, and then that is to the 3rd. On that one, you have a power to a power, so you can multiply those together and get 2/5 to the 15th, right? 5 times 3. Then we notice that the more times you multiply a fraction, the smaller it gets. So 2/5 to the 15th power is actually smaller because it's a fraction multiplied by itself more times. That brings us to this one. 8 is a perfect cube. 8 can be rewritten as 2 to the 3rd power. And that, of course, is to the 6th power. So overall, that equals 2 to the 18th power. Each of these 4s are actually 2 to the 2nd power. This one would be to the 5th, and this one would be to the 3rd. That gives us 2 to the 10th times 2 to the 6th when you break it down. And when you multiply those together, of course, you add the exponents, giving you 2 to the 16th. And 2 to the 18th is greater than 2 to the 16th because it's got a bigger exponent with the same base. And last up, 9 can be rewritten as 3 to the 2nd power. And that, of course, was to the 15th power. So when you use the power to a power rule, you get 3 to the 30th power. Over here, 3 to the 10th cannot be reduced. But 27 to the 5th can be. 27, of course, is 3 to the 3rd power. And then that would be to the 5th power, making the whole thing 3 to the 15th power. You would then multiply these together, and so you would add the exponents and get 3 to the 25th power. And of course, since they have the same base and 30 is the bigger exponent, that is the bigger number. We continue. Here we are multiplying, so we multiply the coefficients and get 6. We add the exponents on the n and get n to the 10th. Same thing in number 9. We multiply the coefficients and get negative 20. We add the exponents, x to the first and x to the first gives us x to the second. Here you would need to do this first, apply that 2 to each thing in parentheses. You would get 9x to the second power. You are multiplying that times 7xy. Now you're ready to multiply the coefficients together and get 63. You've got 2 x's and 1 x, which gives you x to the third, and you've just got the 1 y, which gives you y. Here you're going to do the power to a power rule. That would be p to the 4 times 7, which is 28, p to the 28th. Here you would need to apply the 2 to each thing in parentheses, giving you 3 to the second, x to the third to the second, y to the 6th to the second. So 3 to the second then equals 9. On the variables, we're going to use the power to a power rule, giving us x to the 3 times 2, which is 6, and y to the 6 times 2, which is 12. Over here we have a quotient in parentheses. So we're going to apply the 2 to each of the 4 things. That gives us 5 to the second power. Oops, I forgot. X to the 4th to the second power. Over 7 to the second power. Y to the second power. Let's go ahead and apply all those. 5 to the second power is 25. X to the 4th to the second would be x to the 8th because you would multiply the exponents. 7 to the second is 49. And y to the second is y to the second. My favorite way to do these that have a negative exponent, of course, is to just make them a fraction. So I make it a fraction by putting it over 1. And then I know I need the reciprocal of x to the negative 5th. But taking the reciprocal just means move it to the opposite spot in the fraction. And I end up with 3 over x to the 5th. Right? Moving the x to the bottom, turn the exponent positive. In number 15, I just need to reduce. I would start by reducing the coefficients, 8 over 10. 2 goes into both of those numbers. So 8 divided by 2 gives me 4, and 10 divided by 2 gives me 5. And the variables I'm going to cancel out, right? I have 2 m's on top and 1 m on the bottom. So when I cancel out, there'd be an m left on top. The n's have 4 n's on top and 7 on the bottom. So when I go to cancel out the n's, I'm left with 3 n's on the bottom. And the p's, of course, 5 on top and 3 on the bottom. When I cancel them out, I end up with 2 on top because there's 2 extra on top. 16 is a little bit trickier because of the negative exponents. Let's walk through it. I would start with the 9 over 12. Both of those can be divided by 3. 9 over 12 reduces to 3 over 4. Now the x's. I've got this negative 3 on top. That, of course, moves it to the bottom. But the one on the bottom is staying there. So now I have all 4 x's on the bottom. The y's both have negative exponents, so they're both going to switch places. The negative 7 is going to move to the top, and the negative 2 is going to move to the bottom. That's a mess. But the bottom line is I end up with 7 y's on top and 2 y's on the bottom. So when I cancel them out, I end up with 5 extra y's on top. And the z's don't go anywhere. I just cancel them out. There's 5 on top. There's 3 on the bottom. Oops, those aren't z's. Well, there's 2 extra z's on top. There you go. All right, 5 more. Again, I would make this a... Oops, what happened there? All right, I would make this a fraction, and I would take the term that's got a negative exponent on it and move it to the bottom, and that's going to give me 5x over y to the 7th. 2 to the negative third, when it's just a single term, I don't make it a fraction. I just take the reciprocal of 2, and that turns the exponent positive, right? Everything to the 0 power equals 1. All right, here I have a little work to do. First, I need to do this part of the problem. I need to apply the 3 to each thing. 2 to the 3rd power is 8. 2 times 2 times 2. X squared to the 3rd power. I'm going to multiply those because it's a power to a power. And I would then multiply that times 5x to the 4th. And of course, when we multiply things, we multiply the coefficients and we add the exponents. I now have 40x to the 10th. And over here I have 5x to the 9th. And since those are not like terms, that is my final answer. All right, the last one of these, I just need to do some multiplying. I will multiply these together. I will multiply these together. Since I'm multiplying, I'm going to multiply the coefficients. I'm going to add the exponents. And the same thing over here. I'm going to multiply the coefficients, but I'm going to add the exponents. These are like terms, so they can be combined. And 20 minus 15 of these gives me 5 of these x to the 7ths. All right, just a couple more. All right, in this problem, I have 15x to the 8th. And I want to look at what sign 15x to the 8th would be. So I like to write it like this. That is 15 times x to the 8th. The important thing here is I am multiplying two things together, and I want to look at the sign of both. Of course, the 15 is always positive. So let's put a positive under that. But x to the 8th might change depending on what type of number I put in for it. When I put a negative number in, like say negative 2 to the 8th power, a negative number to an even exponent, we have learned, ends up being positive. Right? So this ends up being actually positive, and I have a positive times a positive, which of course would be positive. All right, how about if I put a positive number in for x? Well, if I put a positive number in for x, like 2, it's still, positive numbers are always positive. So I still end up with a positive 15 times a positive result here, and a positive times a positive is going to end up positive. And last up, if I put 0 in for x, that ends up being 0, and any positive number times 0 is 0. All right, let's look at 23. It might be a little more interesting. In 23, this is my expression. That would be negative 11 times x to the 17th. And again, let's write the sign of each number underneath it. Negative 11 is always going to be negative. It's negative 11. X to the 17th, though, might change depending on what type of number I put in for it. Let's start with the negative number. If I put a negative number like negative 2 in for the x, we have learned that a negative number to an odd exponent is negative. Right? You multiply a negative number by itself an odd number of times, it ends up negative. So then when you multiply this negative 11 times x to the 17th, you end up with a negative times a negative, and that, of course, would be positive. Let's look at B. What if I put a positive number in for x? Well, like positive 2. Well, a positive number to the 17th power, any positive number, always ends up positive. So now I end up with a negative 11, which is negative, obviously, times a positive result for x, and a negative times a positive is negative. And then last up, 0. I don't know if I need to always do this one. When you put 0 in for x, 0 to the 17th, of course, is 0. And a negative number times 0 is 0. All right, last problem. This is kind of a story problem. They're talking about the distance from home to school. And the important thing you need to know about the distance between any two things is it's positive. Distance must be positive. So this distance is being represented by this algebraic expression. And we want to know what values of x make sense for this expression. Well, the only values that make sense are those that make the expression positive, because it represents the distance, and distance has to be positive. So what you're really being asked here is, what values of x make this expression positive? Well, let's look. This is negative 3 times x to the 7th. It says in answer A that x must be positive. Let's see if positive numbers work. Ruh-roh. So if I put a positive number in for x, like say 2, then I would get a positive result. 2 to the 7th would be positive. And of course, negative 3 is always going to be negative. So when I multiply negative 3, a negative, times a positive result for x, a negative times a positive is negative, and that cannot work. X cannot be positive. Choice A does not work. I may have missed that when I gave you the answers. Choice B. X must be a negative number. Well, let's try a negative result for x. Well, so negative 3, of course, is always going to be negative. If I put a negative number in for x, like say negative 2 to the 7th, now negative 2 to the 7th ends up being negative, right? Because I'm taking a negative number and I am multiplying it an odd number of times. We have learned that a negative number to an odd exponent remains negative. But the final result now would be a negative 3 times a negative result for x. A negative times a negative is positive. X can be a negative number. So this could be the answer. But we need to check the others to see if maybe there's a better answer. The value of x can be any integer. Well, saying it can be any integer means, of course, it could be a negative integer, but it could also be a positive integer. And as we saw from part A, it cannot be a positive integer. Positive numbers don't work. So it cannot be answer C. And last up, the value of x can be any number other than 0. Well, any number other than 0 would include positive numbers. And again, as we saw from part A, positive numbers don't work. So that can't be the answer. The answer should be B. All right? Hope that helped.